So in the last video, we discussed till question 7 of mathematical methods for economics, past year 2023. And in this video, we'll be covering the rest of the questions. Okay, we'll start with question 8. Find elasticity of y with respect to x when f is given by this thing. So we know elasticity is change in y by change in x into x by y. And with this given function, we can use implicit differentiation. This would give us 3x square y cube. So using the product rule, then 3y square y dash into x cube plus 9x square should be equals to 0. Now taking 3x square common, we have y cube plus 3x square common y square y dash into x plus 3 equals to 0. So either x is 0 or this. So we will have either x equals to 0 or so we have, I need to write it again. So using implicit differentiation, we had 3x square y cube plus 3y square y dash into x cube plus 9x square should be equals to 0. Now taking 3x square common, we have y cube plus y square y dash x plus 3 should be equals to 0. So either this needs to be 0 or this term needs to be 0. So if this is 0, if this term is 0, we have y cube plus y square y dash x plus 3 equals to 0. So y square y dash x is minus y cube minus 3 and y dash would be minus y cube minus 3 upon y square x. So y dash, which is del y by del x, which is same thing as change in y by change in x. So elasticity is change in y by change in x into x by y. So this would be minus y cube minus 3 upon y square into x multiplied by x divided by y. X cancels out. So we have minus y cube plus 3 upon y cube. So elasticity would be given by this. Okay. Now moving to the next question. 8th question, B part. Okay, the question is, for what values of the numbers alpha and beta does the function, this is the function given to us, have the maximum value f of 2 equals to 1? So we know with the help of first order conditions, we can find the critical points. So f dash x, the maximum value is coming out to be at 2. So 2 would be a critical point. So f dash x is, we'll take the product rule again. Let alpha be common, then let x be the first function, e to the power minus bx be the second function. So first function into derivative of second, which is minus b times e to the power minus bx, plus derivative of first function, which is derivative of x would be 1 into e to the power minus bx. So this is what f dash x is coming out to be. Now if we solve this, I'll write it here. It is alpha x minus alpha beta x into e की power minus beta x plus e की power minus beta x. This is coming out to be 0. So if we take common, what we are left with is minus alpha beta x plus 1 equals to 0. This cannot be 0. So, and we can, so alpha is also common. Alpha was common initially, so it would be plus alpha times this. So alpha is also common. So we are left with minus bx plus 1 needs to be 0. So this means 1 equals to bx beta x, and beta would be equals to 1 by x. So this would be a critical point. So x equals to 1 by beta is a critical point. Same thing. And we know x equals to 2 is a critical point. So 1 by beta equals to 2. So this implies beta equals to 1 by 2. I hope till this it is clear. And now we know f of 2 is 1. So putting the value of x equals to 2, we have alpha x would become 2 e to the power minus 2 beta is coming out to be 1. And with the help of the first order conditions, we know beta is coming out to be 1 by 2. So we have 2 alpha e to the power minus 2 into 1 by 2 equals to 1. So this is minus 1. This would be 2 alpha upon e is coming out to be 1. So alpha would be equals to e by 2. So we have got values alpha equals to e by 2 and beta equals to 1 by 2. Now we have already found this. We need to show that, okay, since you have already found this, you need to show one more thing. We have already found f dash x. You need to show f double dash x needs to be less than 0 when alpha equals to e by 2 and beta equals to half. We have found f dash x. You will need to differentiate this again. You can do these calculations and you need to put these values to see. So it would be a maximum value only if f double dash x is strictly less than 0. And you can see, you will find it. Okay, I'm not doing these calculations because it will unnecessarily take extra time. So this is, okay, okay, so far what we have is, this is alpha times this. So you need to differentiate this again. Same product rule you will use. And then for f dash double x, you need to put the value of alpha equals to e by 2 and beta equals to half. You will see the value is coming out to be less than 0. And then only we would be able to say that f dash double dash of 2, because 2 was our critical point. So this would be coming out to be less than 0 given these values. And then we can say it would be a maximum value. Okay. Now moving to the 9th question. Let alpha and beta be positive constants. Find limit. So this is limit x approaches 0 plus 1 minus 1 plus x to the power alpha whole power minus beta upon x. Now when x approaches 0 plus 0 to the power something, this would approach towards 0 only. So we would be left with 1 to the power minus beta, and 1 to the power minus beta where beta is constant, so this would be 1 only. So 1 minus 1 upon x, limit as x approaches 0 plus, so the denominator would also approach 0, the numerator is approaching 0, so we have a form 0 by 0. So we will use L'Hopital rule. So basically limit of this function would be, so suppose this function is fx by gx, so this limit would be still equal to f dash x upon g dash x. Okay, so I'll just make some space here. So we need to find the limit. So the derivative of the denominator would be 1. The derivative of the numerator would be minus of, the minus sign is already there, into minus beta 1 plus x to the power alpha. Okay, it would be 1 plus x to the power alpha minus beta minus 1 into alpha x to the power alpha minus 1 upon 1. So this minus sign will cancel out. So we are left with alpha beta 1 plus x to the power alpha minus beta minus 1 into x to the power alpha minus 1 upon 1. So this would be our final limit as x approaches 0 plus. Now it would depend on what value alpha takes as well. Okay, so this function can be written as alpha beta x to the power alpha minus 1 upon 1 plus x to the power alpha beta plus 1. This is our final function that we're getting. Okay, now looking at this limit, if alpha equals to 1, then 1 minus 1, this term would become 1 minus 1 0. So x to the power 0, this whole term would become 1. Alpha is 1, so we would be left with, in the numerator we have beta, in the denominator 1 plus x to the power alpha when alpha is 1 to the whole power beta plus 1. And if as limit x is approaching 0, this 1 plus 0 to the power 1 would be, okay, so we will have 1 plus 0 to the power 1 into beta plus 1. So this would be 1 to the power beta plus 1. So this is 1 only, 1. So this would be the limit when alpha equals to 1. Okay. Now when alpha is greater than 1, the numerator is alpha beta x alpha minus 1, 1 plus x to the power alpha beta plus 1 as limit x approaches to 0 plus. So this power, if alpha is greater than 1, this power would be greater than 0. So x to the power 0, where x is 0 itself, so 0 to the power something, 0 to the power some positive number a would give you a value 0 only. So the numerator is going towards the value 0. Whereas if you talk about the denominator, 1 plus x to the power alpha, where alpha is greater than 1, so this is also 0 to the power alpha beta plus 1. So this would be 1 upon 1 to the power beta plus 1, which is 1. So the whole value when alpha is greater than 1, the limit is approaching towards 0. Similarly, we'll take the third case. Okay, I'll draw this here. Similarly, we'll take the third case when alpha is less than 1. So limit at x approaches 0 plus alpha beta x upon alpha minus 1, 1 plus x to the power alpha beta plus 1. Now when alpha is less than 1, so this would be less than 0. So we'll have beta 1 plus x to the power alpha whole power beta plus 1 divided, so this power would be negative. So suppose alpha minus 1 equals to coming out to be, suppose z, and this is less than 0. So suppose if z is a positive number, the value is minus z. So it would become x to the power z here. Because x to the power minus z in the numerator, this would become x to the power z in the denominator. And we will just remove this. Okay, so if it is minus z. Now, as limit as x approaches 0 plus, this term would approach towards 0. So the numerator is approaching towards alpha into beta. The denominator is approaching towards 0. So the whole value is approaching towards infinity. So we would have three cases when lambda is... Okay. So I'll tell you how we proceeded in this question. First, okay, I'll just erase this part. Okay. First, we see the... Okay, let me just erase this. Okay. It is of the form 0 by 0. We use L'Hopital rule. We get the function, the new function, and for specific values of alpha, we will get different values for the limit. Okay. Now, question 9b part. It is estimated that t years from now, the population of a certain town will be... So this is the function which shows after t years. After t years, what the population would be from today. And we are supposed to use differentials to estimate the amount by which the population will increase during the next 6 months. So t is given in years and we are supposed to ask about what the population would be in after 6 months. So using differentials, so del ft would be equals to the derivative of 40 would be 0 and the derivative of 8 by t square would be, so u dash, this is suppose u and this is v, so we have u dash would be 0 into v t plus 2 minus derivative of v, which is t, into 8, the function t plus 2 whole square. So we are left with 8 t into dt. Well, just it's a lot of... Okay. So del ft would become, so we are differentiating it with respect to time. It would become, the derivative of this is 0, and if you will differentiate this, so you have minus 8 common, so 1 by t plus 2 ka whole square ka derivative would be into minus 1 and dt, because we are differentiating it with respect to time. So this becomes 8 upon t plus 2 whole square into dt. Now, if we are talking about 6 months, so 6 months is half years, because t denotes the years from today, from now. So half year would be denoted by 0.6, 0.5. So we have, this would be 8 upon, and currently t is 0 whole square into 0.5. So which is 4 upon 4. This gives us value 1. The population would increase by 1 million. So you need to mention the increase as well. So the population after 6 months is expected to increase by 1 million given this function. Okay. Now coming to question 10. Show that the tangent to the curve y equals to x cube at any point meets the curve again at point z, where the slope is 4 times the slope at c comma c cube. So at c comma c cube, the equation of the curve would be y minus, so the y minus y1 equals to f dash x, x minus x1, we know this. So we have y minus y1 is c cube equals to f dash c into x minus c. F dash c would be, okay, if y is f of x equals to x cube, so f dash x would be 3x square, so f dash c would be 3c square. So the equation is, I'll write it here, y minus c cube equals to 3c square x minus c. Now y is given as x cube, so we have x cube minus c cube equals to 3c square x minus c. Okay, solving this further, this can be written as x minus c into x square plus c square plus cx minus 3c square x minus c should be equals to 0. Taking x minus c common, we have x square plus c square plus cx minus 3c square equals to 0. So x minus c, then x square plus cx minus 2c square equals to 0. So either this is 0 or this term is 0. So this would be 0 when x equals to c. So one of the critical points that we are getting is x equals to c. Now, so at x equals to, okay, this is saving PDF. So at x equals to c, the slope is 3x square, which is equals to 3c square. But we were supposed to find a point z where the slope is 4 times the slope at this point. So now, using the quadratic equation, we can solve this. So x would take value minus c plus minus b square is c square, minus 4ac, minus 4 times ac is 2c square, the minus sign. So it would be minus would turn out to be positive upon 2. So x would turn out to be minus c plus minus 9c square upon 2. So this would be minus c plus minus 3c upon 2. So the value of x would be x would take value minus c plus 3c upon 2 minus c minus 3c upon 2. So this is nothing but c, and this is minus 2c. So we have already solved for c. Now if x is minus 2c, the slope, if we talk about the slope, okay, if x is minus 2c, y is minus 2c cube, which is minus 8c cube. Now the slope is 3x square, so 3x square minus 2c whole square, so this would be 12c square. So it is 4 times the slope. So we are getting 4 times 3 times c square. So at this point the slope is f dash c was 3c square, and at this point we are having the slope as 4 into 3c square. Okay, I'll just erase this up. So at this point this condition is being satisfied, that the slope is 4 times the slope at c comma c cube. Okay, we'll move on to the next part. Now moving to this part, we have if f and g are continuous function in a comma b. So the interval is a comma b including a and b both, such that f of a is greater than g of a. We know f of a is greater than g of a, and f of b is less than g of b. So we know f of a minus g of a is greater than 0. F of b minus g of b is less than 0. Now suppose if we define a function hx as f of x minus g of x, and since the function f is continuous in the interval a comma b, the function g is also continuous in the interval a comma b, so the function h would also be continuous in the interval a comma b. Now h of a is f of a minus g of a, which is greater than 0. It is already being given in the question. H of b is f of b minus g of b, which is less than 0. Now with the help of the intermediate value theorem, we can say there would exist a c between a and b such that h of c equals to 0, which means f of c minus g of c equals to 0. So f of c is equals to g of c at point c. So we can prove this. So this was quite easy. You just need to remember the intermediate value theorem. Okay. Now we have come to section C. You are supposed to attempt any two questions. Find the third. Okay, this is saving PDF. Find the third degree Taylor formula for log 1 into x 1 plus x at 0. Use this to approximate log 1.1. Estimate the upper bound to the error R3x. Now we know the Taylor formula would give us the approximation, and since we are asking for a third degree approximation, the fourth derivative would give us a value. The fourth derivative would give us the value at the constant c that we consider, which lies between 0 and x. Okay, now the function is f of a, f of x equals to f of a plus f. Okay, I'll write the formula first. F of a plus f dash a into x minus a upon 1 factorial plus f double dash a into x minus a ka whole square upon 2 factorial, then f triple dash a upon 3 factorial into x minus a square plus 4 dash c at c 4 factorial into x minus a to the power 4. So this would be the remainder. Okay. Now since we are not talking about the remainder right now. Okay. Now for log 1, f of a, f of 0. So the function is log 1 plus x. So when f of 0 would be log 1, which is 0. So we have, okay, I'll write this here. F of x would be equal to 0 plus f dash a. So it would be f dash 0 1 upon 1 plus x. As x is 0, so this would be 1. So 1 upon 1 into x. Then f double dash a. So f double dash a, okay, for log 1 plus x, the first derivative is 1 by 1 plus x into 1. The second, this is f dash x. F double dash x would be minus 1 by 1 plus x square. Sorry, 1 plus x whole square. And f double dash 0 would be minus 1 into 1 plus 0. So which is minus 1 only. So we'll have minus 1 times 2 factorial into x minus 0 whole square. So x square. Then we need to find the derivative of this. So if you'll, yeah, this is basic only. So if you'll solve this, you will have, it would be plus 2 times, so it would be 2 times 1 plus x to the power 3. This is a minus sign. We can use the quotient rule. You will solve this. So this would be 2 by 3 factorial into x cube, and then the remainder at c. Okay. So now you're supposed to, so this would give you the third degree, okay, except the remainder, this would give you the third degree Taylor formula for log 1 plus x. Now you are supposed to find the approximate value of log 1.1. So x takes value 0.1, because we can see log 1 plus x equals to log 1.1, which means x equals to 0.1. And if x takes value 0.1, you can substitute the value of x here, 0.1. This would be 0.1 square, and this would be 0.1 cube. So if you will solve this, you can use the calculator to solve this. You will find value close to 0.1 minus 1 into 0.1 square upon 2 by 6 into 0.1 cube. So this value would come out to be close to 0.953. So this would be the approximation. So this would be the approximate value. Okay, it has. Okay, I hope you had this. So the approximate value for log 1.1 would be close to 0.0953. So you can use the calculator to find that calculation. Now coming for the talking about the error. So this value, the mod of this value, so we were talking about the derivative. We had 2 by 3 factorial. Oh, this was 2 by 3 factorial 1 plus x. Okay, first function was log 1 plus x. We differentiated it. It would become 1 upon 1 plus x. Then the second derivative was minus 1 upon 1 plus x square. The next derivative would be 2 upon 1 plus x cube. The next derivative would be minus 3 upon 1 plus x to the power 4. 3 into 1 plus x to square. Yeah. So this remainder would become minus 6 times. This would be minus 3 into 2, because this is already there. So minus 6 times. And since we are talking about c, which lies between 0 and x, and x we took as 0.1. So minus 6 upon 1 plus c to the power 4. So if they have asked about the third degree Taylor formula, then for the when we are differentiating it for 4 times, we'll find the value at c to find what the value of the remainder would be. And 1 by 4 factorial into x to the power 4. So we know this would be, if we take the value of x, which is 0.1 to the power 4, minus 6. So talking about minus 6, 4 into 3 into 2 into 1. So this cancels out. So the mod value would be 4, 1 plus c to the power 4. So this would be the value of the remainder. And we can see 0.1 to the power 4 upon 4 into 1 plus c to the power 4 would be always less than equal to 0.1 to the power 4 upon 4. Because 1 plus c would be always greater than equal to 1. And if c is strictly greater than 0, so 1 plus c would be always greater than 1. So if we take the condition that c strictly lies between 0 and x, then 1 plus c would be strictly greater than 1. And so this is coming in the denominator. The denominator 4 into this, 4 cancels out, suppose. So if we compare 1 plus c to the power of 4 and 1, we know this would be greater. So since it is coming in the denominator, this value would be lower. So this is the maximum value the error can take. This is the maximum possible value for the error. If we are finding the third degree linear approximation, linear approximation would be a first degree. Third degree Taylor formula for log 1 plus x. Okay, now moving to the next part. Show that the function fx equals to x into mod x has an inflection point at 0, 0, but f double dash does not exist. Draw the graph. Okay, now the function fx would be, so for x greater than 0 for x greater than 0, mod x can be written as x only. So the function would become x square. For x less than 0, the function would be, mod x would be written as minus. So mod x would be written as minus x for x less than 0. The function would become minus x square. So far we know the function fx is x square for x greater than 0 minus x square for x less than 0. F dash x would be 2x. Here it would be minus 2x. F double dash x would be, so it is saving PDF right now. F double dash x would be 2 and f double dash x in this case would be minus 2. So we know for values of x less than 2, if the second derivative is negative throughout, so the function is concave. So suppose it is equal to, one side it would be equal, and when f double dash 2 double dash x is coming out to be positive throughout, we know the function is convex. So if we have x here, for value of x less than 0, the function is concave, and after that it becomes convex. So we can see f double dash would change sign here. So 0 inflection point at 0, 0. So there is a inflection point here because the sign is getting changed. And you can use the intermediate value theorem as well. Below this point, f double dash c is less than 0. After this point, f double dash c is greater than 0. So at this point, f double dash c should be equals to 0. But now what they are asking is that we need to show that f double dash 2 does not exist. Now we can see if we are coming from the right hand side, f double dash 0 would take a value of 2. F double dash 0 would take a value of 2 if we are coming from the right hand side of x, because the function is like this. So if we are coming from this, f of double dash 0 is taking value 2, whereas if we are coming from the left hand side of x, the value we are getting is minus 2. And since minus 2 is not equals to 2, because the left hand side limit is not equal to the right hand side limit, so the derivative does not exist at that point. Okay, now moving on to the next question. Okay, we are left with 2 questions. Okay, we'll start with 12th. Now the function is given as fx equals to 3 upon x to the power 4 minus x square plus 1. Now f dash x, so we are supposed to determine the intervals for which the function is increasing or decreasing. So you can find an interval from 0 or other values depending on what values it will take, and then you can check for the specific intervals whether for the interval f dash x is coming out to be greater than 0 or f dash x is coming out to be less than 0. So in this case it would be increasing, in this case it would be decreasing. Okay, now f dash x would be u dash is 0, v something v which is would be 0 only, minus v dash. This would be 4x cube minus 2x. Okay, minus of 4x cube minus 2x into 3 upon x to the power 4 minus x square plus 1 whole square. So look at this thing, the denominator would be positive throughout irrespective what the value of x is because it is a square term. Talking about the numerator, the value is minus 12x cube plus 6x. So we are having this value. So this is equals to 0. So the point would be x in 6x. So this would be 1 minus 2x square equals to 0. So this gives us either x is 0 and 1 minus 2x square equals to 0, which means 2x square equals to 1. So x square equals to 1 by 2. So x becomes plus minus 1 by root 2. So the values of x is 0, 1 by root 2, minus 1 by root 2. And here we have the values of x. So the intervals we have are, okay. So the intervals we have are minus infinity to minus 1 by root 2. Then, saving PDF, minus 1 by root 2 to 0. Then 0 to 1 by root 2. Then 1 by root 2 to infinity. Now you can take value, suppose, so this would be less than 1. Suppose we take a value 1. At 1, this term would be f dash x minus 12 plus 6, which is less than 0. So the interval is falling. So the interval is decreasing. F dash x is coming out to be less than 0. So we'll see in this interval, the function is decreasing. Okay. Now, if you take a value, suppose close to here, suppose you take a value 0.1. This would be minus 12 into 0.1 to the power cube plus 0.6. You will see this value would be, okay, this is minus 12 only, 0.012 plus 0.6. So this is greater than 0. So the function would be increasing here. Similarly, if you will take other values, you will see this is decreasing here and increasing here. Okay. Find the points of local maxima and minima. So at this interval, so the first order conditions are this. With the help of the first order conditions, we are getting the value of x as this and x as 0. So f of 0 becomes 3 upon 1, which is 3. F of 1 by root 2 becomes 3 upon 1 by root 2 to the power 4 minus 1 by root 2 to the power 2 plus 1. So this would be 3. 1 by root 2 square is 1 by 2. So 1 by root 2 power would be 1 by 4 minus 1 by 2 plus 1. So this is 3 upon 1.25 minus half. This is 0.75. So this is 4. F of half is coming out to be 4. F of 1 by root 2 is coming out to be 4. And f of minus 1 by root 2. And since this is power 4, this is power 2, this would also give you the value 4 itself. So what we can say is at 0 we are having a local minima, and at f of 1 by root 2 and at 1 by root 2 when x equals to 1 by root 2 and when x equals to minus 1 by root 2 we are having a maximum value, a local maxima which is coming out to be 4. Now if we want to talk about the global maxima and minima, then limit fx as x approaches infinity from the positive side, positive infinity. So this would be 3, and the numerator, denominator, the numerator would approach 3, the denominator would approach infinite only. So it would be 3 by infinite, which is 0. So the limit would be 0. And if we approach minus infinity, and because the signs are x4 minus x square, so it would still approach 0. So either we go from positive or negative infinity, we'll get to the value 0. So what we can see is that there won't be any global minima, but this would be the global maxima when x equals to 1 by root 2 and x equals to minus 1 by root 2. So this will give us the global maxima as well. Okay, so we are done with this question. So this is the last question that is being left. Okay, the population of a country grows according to the following equation of time. So this is the population that is growing. The growth function is given by this equation. Find del p by del t when t equals to 0. So this is a fairly basic equation. Del p t by del t would be, you can use the quotient rule again. First function, okay, u dash v, derivative of a would be 0, and then some multiply by something multiplied by this term, this would give you 0 only, minus, okay, this would be minus a times derivative of this. So derivative of this would be minus a e to the power minus at upon b plus e to the power minus at whole square. So minus minus a would be positive only. So you will have a square e to the power minus at upon b plus e to the power minus at whole square. Now when t equals to 0, so e to the power minus a into 0 is e to the power minus e to the power 0 only, which is 1. Similarly, e to the power minus at is 1. So we are left with a square into 1 upon b plus 1 whole square. So when t equals to 0, this is the value that we are getting. Okay. Now find the proportional rate of growth of the population. The proportional growth rate is del p by del t upon pt. This dot denotes this thing. So this is equals to p dot t. Now the proportional growth rate would be given by, we have del p by del t, this, so del p by del t was this term, a square e to the power minus at upon b plus e to the power minus at whole square. So del p by del t upon pt would be the value of pt that we, this value of the function. So this is a upon b plus e to the power minus at. So a would cancel out, the square term would cancel out. So del p by del t would be a into e की power minus at upon b plus e की power minus at. Okay, if you will see this function, if you will see this function, so this is nothing but e to the power minus at into, this is pt only, into pt. So okay, this was fairly basic. Now we are supposed to show that population has a limiting value and find its value. I'll just erase these things. Okay, now moving to the third part. The population has a limiting value. Now we need to find limit pt as t approaches infinity. So this is limit as t approaches infinity a by b plus e to the power minus at. As t approaches infinity, okay, this can be written as b plus 1 by e to the power at as limit t approaches infinity. So if t approaches infinity, this term would approach infinity because a is positive and t is also positive, so this would approach infinity. E to the power infinity would approach infinity, and 1 upon something infinite would approach towards 0. So the limiting value would become a upon b. Okay, now at what time is the population rising most rapidly? Okay, so okay, at what point is the population rising most rapidly? So we know del p by del t gives you the rate of change of population. Rate of change of population. The population would be rising most rapidly when the first order condition of del p by del t, which is del 2p by del t square, would be 0. This is the rate of change of population, and it would be maximum when we find this critical point. So for some value of t, we will have del 2p by del t2 needs to be 0. Okay, this is the basic calculations only. We have del p by del t with a, okay, this is saving PDF. We have del p by del t. You need to differentiate it again, and then you would be able to find the value. Now coming to the last part, the initial value of a rare diamond is given as ft equals to this. So this is the initial value of a rare diamond. Now if the interest rate is compounded continuously and it is 7%, so what we know is that the interest rate is 7%, which can be written as 0.07. How long should the painting be held? Of a rare diamond is how long should the rare diamond be held? Because the value is getting discounted, and for continuous compounded continuously, the present value is k into e to the power minus rt, and k is initial this value. So the present value, this is the initial value, so the present discounted value would be ft into e to the power minus rt, which is 25,000 into 1.75 to the power 4 root t e to the power minus 0.07 t. So this is the present discounted value of the rare diamond. Okay, now to know at which particular point would this present discounted value would be maximum, we need to differentiate this with respect to time. So 25,000 is common. Now if we differentiate this, so first function into differential of second, minus 0.07 e to the power minus 0.07 t into, this is the derivative of the first function, into 25 or 25,000 we have already taken common. So into 1.75 4 to the power root t. Then second function as it is, e to the power minus 0.07 t, the derivative of this. So the derivative of ax is ax log a. So derivative of 1.7 to the power 4t would be 1.75 to the power 4t into log 1.75 into derivative of this. So derivative of this would be derivative of 4 root t with respect to t would be 4 into half t to the power minus half. So this is 2 by root t. So into 2 by root t. So this would be the final value. Now we need to find the value such that, okay, we can further simplify this. So 25,000 is already common. We'll take common. What all things are common? This is common, this is common. So we'll take into 1.75 to the power 4 root t into e to the power minus 0.07 t. So this we have taken common. So this is considered, this is considered. We're left with minus 0.07 plus, we have considered this, log 1.75 into 2 by root t. So this needs to be 0. This is positive, this is positive, this is positive. This cannot be 0. So we are left with this value needs to be 0 for the first order condition. And if we solve this, we have 0.07 equals to log 1.75 into 2 by root t. So root t becomes log 1.75 into 2 upon 0.07. So t becomes log 1.75 upon 0.07 into 2 whole square. So when t takes value this, the value of the rear diamond, okay, saving PDF. So the value of the rear diamond would be maximum at that point. So we have completed the MME past year 2023. Now I'll do micro past year 2023, then stats for first year 2023, then we'll go do again MME of 2022, then micro 2022, then stats 2022. So the NEP syllabus is being confined to these 3 papers only, but solving these papers, only the relevant parts, you'll get an idea about what type of questions they are asking and how you are supposed to proceed in solving that type of questions. So okay, so I'll upload this in a day or so. Okay, I hope this was clear. Thank you.